Okay, I'm just waiting for this live stream to go live, waiting for us to come on air. And, oh, okay, we're green. Helena is with me. I know it's a little bit past her bedtime, but she has asked me what I was doing tonight. And I thought, well, okay, that's time to go live with something. I am soldering. Now, I've got a few jobs I'm going to solder on tonight. Probably the most, I suppose the most important one at this point. This is a CNC board from a chap, Lee Lipinski, who sent this to me to fix and work on. And it's exhibited a few problems. It's actually the second time it's come back to me because I sent it back to him with probably insufficient testing. I've already replaced these two resistors here, and upon trying it in my own CNC machine, now some of the connectors are different. What happened is the spindle turned just a little bit without the spindle switch being on, and then the fuse over there immediately blew. Now, the spindle switch on this is actually supplying, there's a chip here, a 555, which does the control signal to the spindle via this transistor, and the transistor on this particular board is conducting all the way through. So it's failed, and when these ones fail, they fail lethal. They fail such a way that the current just goes all the way through. I don't think it's destroyed the 555. I can check that later, but I think that's been one of the underlying symptoms. So that's one of the jobs. The other thing, I think, just for fun, because this one's been asking, Daddy, what's soldering? I've not seen you soldering.
Yeah, what is soldering?
So I'm also going to solder this up. This is actually a little bit dated. It's a slice of Pi I/O board, which is actually for a Raspberry Pi 1. It doesn't really matter. We can solder that up anyway because it's more fun soldered up. And Helena's going to have questions. She's also going to keep her eye on the chat window, which for us is over there. So if you see her eyes going over there or my eyes going over there, that's because that's where the chat window is. Whereas here I've got feedback so I can see what you're seeing. Okay, Helena.
But Dad,
yes?
why on the other screen it's not the same?
Because there is a lag. So we're seeing here what's our immediate monitoring, and seeing over there is a few seconds behind.
That's funny.
Yeah.
That's weird too.
It is a bit disconcerting, which is why we've got to have a monitor here, the one we're looking at. Otherwise, we're going to end up looking over there, and or we'll be thoroughly confused by that.
Like what?
Yeah.
What's happening?
We have two watchers. Hello, both of you. I don't know if it shows me. Well, say hello anyway. So we'll try and introduce some of what I've got here. Helena was asking a little bit about soldering. Presumably, you know what this bit is.
I don't.
Okay, this is a soldering iron, and it's pretty. I say it's a fairly simple device. When it's turned on, and I've already turned it on, so it's hot already. It gets hot, and it gets hot enough to melt solder. And solder is, I suppose, it's a low melting point metal. So in this case, it's going to be a mixture of tin and lead. This is leaded. Oh, hello, Lee. So it's a mixture of tin and lead. And when I touch it to the iron, you'll see it melts. Now there's a smoke coming off there, and that smoke is going straight into this extractor. People may hear the extractor, and I'm sorry about the additional noise. Hopefully my microphone is accounting for that, and you're hearing me and Helena, and not the sound of the fan.
Yeah.
You know why we have the fan, Helena?
Just in case it gets too hot.
No, it's because of the smoke coming off of this. So the flux smoke here is not very good to breathe.
Yeah, might cause an illness.
Okay, so you were then asking about this stuff.
Yeah, what is it?
So I'll get that closer to the camera. In fact, let's go and swap.
Switch screens.
Yeah. All right, you can still see me. You can still see. So Helena was talking about this little pot here, and this is a tip tinner and cleaner. So tinning means covering something in a little bit of solder, and generally it's easier to solder with a tin tip, because if the tip is bare, it's going to get oxidized. It's going to get oxidized, rust on it. And the thing is, rust, heat doesn't go very well through rust. It goes very well through metal. But once it gets rusty, as in it gets oxidized, the heat doesn't go so well through it and it won't do its job.
Oh, so that's basically a cleaner.
That's it. So it melts in here. It creates some horrid smoke going straight to the extractor.
Great.
And so it's both a little bit of solder and also a little bit of kind of an acid flux to clean it. So then I use this just to clean it off. So this springy stuff, it's just, you kind of stab it with solder, and there you go. Look, it's nice and silvery, and you can see where I've not poked it all the way in because you can see a ring of oxide. Oh, look, Lee has said hello, Helena. Hopefully, I spelt your name correctly.
You didn't. You didn't.
Be nice. Be nice. Come on, tell him about that.
I spell my name
To the camera.
H-E-L-E-N-A.
You be nice. Right. Anyway.
H.
Okay. So that's what that's all about. So we've got the solder, we've got the tip tinner. This is for removing solder. This stuff.
So you can desolder.
Oh look, Lee has your name correct now. Give him a thumbs up. There you go. Awesome. So this is from removing solder. So sometimes you're soldering stuff in, sometimes you're removing stuff. So for this board over here, we'll be just adding stuff. For this board here, we've got to remove stuff. And to be honest, removing stuff is more annoying than adding stuff with soldering. Okay? Cool? So that's soldering wick. And it's like a braid with a bit of solder already in it. And when you heat it up, the braid sucks solder up. And then when it's kind of used, you cut a bit off and get a fresh bit of solder in. Okay?
Oh, but how is there so much in that tiny tin? I wonder.
There isn't that much left, really. I've already used quite a lot.
Wow.
Okay.
So
Presumably you know what this is. Actually, I'm probably not going to need...
resistor.
Good. I'm not going to need those, so let's put those aside for now. Because we've already got the resistors we need, unless they've been destroyed already. Because as I said, the spindle turned just a little bit, and the fuse blew. So I'm thinking that this transistor here went fully conducting, or stays fully conducting. So I've already removed the screw. So there was a... let's see if I can get that up there. So I've got it clamped so I can actually work on it. So there's a screw there holding this transistor into the heatsink. And I've already pulled it vaguely sideways with the pliers. And this is tricky because what I have to do is I have to heat it up enough for the solder to become basically wet. And then I've got to pull on it with ease. So this blue thing is just a clamp just to hold it in place, give it a bit of weight. And so I'm not actually holding the board directly because this is very hot and the board will get hot. And I don't really want to burn my fingers. And here I got 3 spare transistors, which actually Lee has sent me. And I've looked at the data sheet, and they look like they're suitable replacements. They can carry the same, so they can do the same job. Do you know what a transistor does?
No, I don't even know what a transistor is.
It's a switch, but it's a switch where you can turn it on electrically. So imagine you've got something putting out signal power, low power, and then something else has got to handle motor power, and that's exactly what this is. So on one of these pins you've got signal power controlling a higher motor power on the other across the other pins. Make sense?
Makes sense now.
Because if you try to put motor power directly across some of these chips, they'll go bang. And in this case, actually, the motor is a... Exactly, that, yeah. Lee will chuckle away when I say, actually, blowing up is kind of what these things have done a few times, because mine's done it a few times, and this one has done it. It's blown a fuse, so this is a fuse. Do you know what a fuse does, Helena?
It, when it blows up, it will... I don't know.
Okay. Can you see inside? There's a little link.
I'll see on the screen.
Okay, let me hold it up. Oh, see if I can get it to focus.
Perfect.
Here we go. You see the little link?
Oh yeah, I can see the little...
Can you see the little link is kind of broken across one side there?
Yeah, that means it might blow up.
Well, it's blown. It doesn't go bang. It just kind of goes fizz and just stops. So you've got 2 metal ends and a wire through the middle. And when the fuse is working, then the electricity can go through the wire in the middle. But if you put too much power through in it,
it'll go.
Yeah, the wire burns out. Well, it doesn't go bang, but the wire burns out and it stops too much power getting anywhere else.
So it's already done it, so, and because it's so hot, it melts it basically.
Yeah.
Ah, so it's a bit like that.
Kind of. When you put electricity through things, they tend to get hot, and it's a safety device. Well, no, it just one bit will probably just go cherry red and then pop. Yeah. Now this old fuse is good only for the
type of red. Or much
the
red.
viewers can't see that. That's an LED. Hold on.
I know.
Camera's getting to focus. Come on.
Focus,
well, this is probably confusing it. Actually, it's probably it looks like it's focusing on that. Let's just come on.
Hello, camera. You need to focus it.
Yeah, no, it's an automatic focus. It just picked up the wrong thing. Okay, so I've got a few other tools. Do you want to ask about any other tools, Helena?
Yes, I do.
Okay.
There's another tool I want to ask about.
Yep.
This thing.
Okay, that's a G clamp. That's just for me to clamp stuff down to the table. Can you guess? Oh, hello, Laser Knight.
Oh, Laser Knight. That's a nice
I might
name.
scroll down there. Actually, I can't quite see. Where's my mouse? Where's my mouse?
Okay.
Let's put it there. So it's designed for holding things down, and I've got the G clamp in case I need to clamp this board further, just in case that board is kind of wobbling. Well, no, it's if this is wobbling, because all this adds weight to the board. If I put pressure on the board, it won't go very well. Oh, hello, loose prop. See, you've broken it again. I don't. I don't think Lee broken it again. I think it was never quite fixed. Unfortunately, that's my bad, because I think I sent it to him before it was quite ready. Can you guess, Helena, why it's called a G clamp?
Because it's a G.
Yeah.
See?
G shape. Oh, you're too close. There we are. Cool.
Oh,
okay.
G clamp.
Alrighty.
G clamp.
So what I'm going to do, I'm going to use a set of pliers. Now, I have already kind of gotten some of the solder off of this, so let's just back that off a bit. And let's just pop it in here now. This is not really strictly the right kind of clamp for this board, but it will do the trick just nicely. And this is the device here. And again, my soldering iron is confusing this camera. Let's take that out of shot and see if it focuses again. Alright, I'm going to try a trick that sometimes works. Come on, find something to focus on. Come on. Yeah, oh, and I'll put that back. Come on.
Oh,
focus problems. Come on.
Oh, come on, automatic thing.
Yeah, I know.
Automatic.
Well, maybe we can. Hold on. Okay, you wish it wasn't automatic. Can I do the... This might cause problems later, but I can get the... Where's the crossbar? There it is. Camera control. Focus. No. Come on. Let's see if I can get it to give me non-automatic focus. Ah, there we are. Right, let's fix focus it. That's still not quite right. Oh, that's a bit mean.
Hey!
Not to
Helena's cleverer than me. Bless her. Helena is cleverer than me. Everyone is cleverer than you. Lipinski.
Right, let's...
I can't even spell CnC. What is that English idiom? Or
oh, sorry, Helena. So, do you know this is a board for a CNC? Do you know what the CNC is?
Is it the one that you printed Helena, the one that you cut wood with?
Yes, it is that one.
It's the one that you made the Helena sign for me.
That's the one.
Helena. H-E-L-E-N-A. I don't know why everyone calls me Helena when I'm Helena.
I don't know.
My name was spelled correctly.
Well, there we are. Right, so I'm just getting the solder now. because this is this board.
What's a that?
What's that? Okay, so this is. There might be a more technical name. Oh no, it's not. Like it says right on it. It's a solder sucker. Let's turn that so the camera can actually see it. Solder sucker, and it does exactly suck solder. CnC, computer numerical control, is what that stands for, Lee. So it's basically you've got those commands that you send, the G code that goes to the CNC or to the 3D printer. Numerical control was where you could set dials and set numbers. C, computer numerical control. I mean, you got a CNC mill. You can have a CNC. I think there's cutters. All the laser cutters are using the same CNC technology in all 3D printers. It might be an overused term, and maybe I should be calling this, I don't know, a router or router or a mill. I just say CNC. It would be nice to have laser printers and other cutters and things, but there we go.
That would be cool.
Yeah, laser cutters, sorry, not laser printers.
Yeah, because you can't print laser.
No, well, the standard printer, you know, black and white printer you get in an office is a laser printer. There's kind of a dial. Right, okay. So what I'm going to try and do... actually, there's still lots of solder. Hold on. Let's get this in here so we can see it. Look. So can you see there's lots of solder there on the top there? Because what's happened is, because this is through plated, which that means that there's... See, you've got the electrical pads here. So the electrical pads have got a hole that goes all the way through for this component, yeah, for this transistor, and the solder gets sucked up through to the top when you kind of solder it in. So I might have to, and I'm going to more delicately rest this to get the right angle on there. I'm going to probably see if I can suck the solder away there. So I heat it up, get that in. Wasn't amazingly effective.
Can't even say his name. Lee Lipinski. This looks interesting. Is this like pumping it up and putting more in?
This is pulling it away, but it is exactly pumping it up. That's the whole...
Is it air? Do you need anything for it, or do you just buy it?
It's just air. It's just an air-powered tool. So all you've got inside there, you got an air... You've got a plunger. So there's a plunger with probably a rubber seal around it.
Or a tube, so then it would go...
A tube, yes.
Maybe it would be
and a big spring.
Solid plastic, so then it could go onto the end and then go... When it pumps, it will go...
That's right. So there's a spring that pulls it out, because that's the spring. Like that. When it pops out, it sucks air through this bit here. There's a bit of a rubber nozzle there, so I can try and get the rubber nozzle right up close to the solder.
Oh, I thought it would be plastic, as in proper, you know.
Solid? No, it's soft. It's soft, so I can kind of get it round corners and squash it in somewhere. However, it wasn't getting me very far here, because of where it is and the angle I'm at.
So you're going to use that?
The solder wick. Now, I'm going to just...
How do you get it off?
I'm not really going to get it off.
Is it metal?
It's metal. What I should not do, what not to do with solder wick, is to hold it there. Because that's metal, and as you know, metal conducts heat. So I hold it there, or you can use some pliers, I suppose. That's another way to do it. And just going to get that in there, and this should suck away some of the solder in there, because there's a bit too much of it. Yeah, we got loads. Okay, excellent.
Best father and daughter time. Smiley face. I get it.
Cool.
Dot D. Because that would equal. E equals. Smiley face.
Oh yeah, the D is a big grin.
Oh yeah, I know that. Like this. My big grins a bit look bad. Don't know why.
Your big grin doesn't look bad. Don't be
Look.
silly. Oh, that's because you scrunch your nose up. That's alright, you're fine. You're fine. Okay, I got some of that off. So the other tool that can come into play, just to make my life a bit easier, because I don't want to pull quite that much stuff through, and I'm going to just going to be cheeky and chop it off. So these flush cutters, and you got here, you see, you got cutters. Yeah, I'll hold them close, but if you look at it, that's a very flat surface, and that flat surface is angled. Yeah. So whatever you're putting them against won't catch on the pivot.
it's like it's a bit like this, but a little bit like yeah, a bit like this in the camera though.
Yeah,
and
that's it.
Then it can go under things.
Well, it can cut extremely close. That surface there, yeah, is extremely nice and flat. So I can, what I'm going to do, just so I got a bit less, now I might regret this, I'm going to leave a tiny bit so I got something to heat up, but I don't want so much to pull through, so I'm going to cut those off. Now I could even cut off the top and then just pull out these. Well, that might be an idea. What if I chop off the top bit, because this is waste, this component is dead. What if I chop off the top bit here, and then I've only got legs to desolder afterwards? That makes it easier. It's a dead component. It's not of any use. It's not like I'm trying to salvage the thing. Let's get in there.
Ooh. It's gonna break. Is it gonna break? Is it gonna break? The whatever it is.
I'm cutting its legs off. That's pretty broken. It's already broken though.
Cut its legs off like
I can't get the third leg.
Oh, you mean that's a little leg.
Best temperature for soldering 6040 lead solder. I gotta be honest, I wing these kind of things.
Ha! Only joking. You wanted what?
Lee, it's basically a wire. I probably should have shown some footage of that, but testing with the multimeter, it's just conducting straight through. Ah well. So I'm afraid to say, loose prop, sorry, that I kind of wing it. I'm not. You'll notice my soldering iron, if I show you the type, it's not got a temperature. It's got a temperature dial on it, but the temperature dial doesn't show you any actual temperature. It's just got quadrants and min and max. So I wing it, and I guess the answer is if it doesn't appear to be doing it, then I'll give it more, and that's it really. I suppose
so
if
it
I
doesn't actually give you numbers like a ruler does.
you can get irons that do. You can get much more. I mean, to be honest, they're more expensive irons. I don't know, well, more modern. This one's about what, 6 years old?
6?
Yeah.
That's as old as my bro.
Yeah, it is. All right, now I've just got one leg to desolder, and then the other leg should come out separately. So now this is where it's tricky because this thing is wobbling, and this was what I was afraid of. Do you have any advice regarding 3D printers, mainly PLA and TPU? Is it worth spending more than 300? I guess it depends on what you're trying to do. I'm just going to move this where I've got some clamping space. I mean, the simple advice is to spring for the best printer you can afford. From what I'm understanding, they're just about to do an update to is it? It's all left me now. No, I'm seeing. I'm answering him because he's asking about the 3D printers to buy.
You need to scroll it down.
No, I can still see the bottom. It's okay. And I'm just clamping this in here. What was I going? Oh, this, the Prusa. They're doing a new Mark Prusa, which means that actually, I think if that's the case, the original Prusa Mark IIIs may be becoming cheaper. Now, I think at the moment you can buy printers for what, 200 quid, 299 or something, or 250 even. They're getting really cheap.
299 is about £300.
Yeah, but they're getting cheaper as well. The thing is, I don't go for the kit form ones. I did buy a kit form one, and although I like to build stuff and I like putting together kits, for your first printer it's a bit painful. It's been a lot of trouble to me, a kit form one. And although, again, you know, okay, writing code and doing stuff with robotics is my forte. Hold on, I'm going to adjust the camera so you can actually see what I'm doing. I've spent more time actually maintaining that printer than printing with it. And I've had to replace lots of parts on it, deal with a bunch of flaws on the kit. Now, my model was a 2014 model, so they've come a long way. But it is a bit of, you know, you got to go, do I want a 3D printer or do I want a 3D printer project? If you get a kit one, you're getting a 3D printer project, not a 3D printer. Just, yeah, that's probably the best way to look at it. So if you can get one that's also solid, I really like the all-metal construction ones. and I was looking. I think was it the Wanahao S3 Mini? I was looking at that as my next printer. But the one I've got is currently working, so I'll be doing more with that.
You broke it.
I broke it just before Christmas. It's working at the moment, though. It's not broken now. It's
working.
I made it live again. Yeah.
The metal long bit broke and it actually went off.
It wasn't the metal long bit. It was the plastic bracket holding in. Okay, we've got this off. There we are. There's the dead one. And now I've got to pull out those stumpy leg bits. I hope that helps you. I hope that helps. Laser Knight, who was asking about the printer.
Thanks for the advice. Yeah, thanks, Dad.
This leg. Oh. Yay! Okay, all 3 legs are out. Now, the next thing I'm going to have to do is clean up those holes. So, before we put the other one in.
Where is the other one anyway?
Oh, and where's the pad gone? Hold on. There was a white pad there. Is it dropped on the floor? Right, we'll have a look for that. Don't worry. No panic. Don't panic. Actually, those holes, yeah, I'll give them. I'll do a bit more solder sucking on those holes just to make sure I can push. Because basically, I've got to be able to get. Well, they will do a bit because they've been. Yeah, look, that's got to be cleaned up. So.
Nothing yet. CnC.
Yeah. So one of the projects I've got planned, and among the many projects I've got planned, there was a rather cool Maker's Muse episode recently where he'd built himself a magnetically attaching build plate, which is what's going in. Maker's Muse, I don't know if you've seen him. Australian guy who does all the 3D printing stuff.
The one the saw one, the one with the saw.
Unless you think, because there's another Australian guy I watch a lot of, which is the EV blog.
EV blog, I know him. You used to watch him a lot in bed when you wake up.
What was the fault? Oh, on my machine. What, the CNC or the 3D printer? Oh, look, there's the pad. Oops.
I know what you mean.
So loose prop. Which machine was that? Sorry. This machine I'm fixing here, or the 3D printing?
Fault machine. What does fault mean?
Problems. I wonder if I can take this out.
Take what out?
So there's like almost. Is that a thermal conducting paste or is that a thermal conducting washer? I'm going to try. Oh, the CNC. Okay, so this board, if I'm right, I don't think Lee's seen it working. And there was... Okay, so when it came to me, this resistor here had been replaced, and this is a 100 ohm resistor going to a sense line. Now, the sense line is actually in parallel to these 2 resistors, and really those 2 resistors should be carrying the current, so that shouldn't have blown. So that meant there was something going wrong in those. Now, I recently found out that these 2 resistors
were burnt.
They weren't so much burnt as they'd gone open circuit and were not doing anything.
Yeah.
And so the reason they'd gone open circuit is they burnt out inside. Last time when this came to me, I'd replaced the 555, which is the timer chip, which was broken, but that was possibly because it had too much current fed to it through a blowout condition. Because the blowout condition to blow these 2 resistors, you'd have to have something quite serious to do that. The fuse had been blown, but I think, Lee, you'd said that the fuse at one point had been replaced with not a fuse. And so...
What do you mean not a fuse? That's a weird noise.
I get you. And what I think was happening is the thing must have kept blowing.
What thing?
The circuit must have kept blowing. possibly because this transistor that we've just removed was always conducting, which would have kept, it was replaced with a nail. Lee didn't do that, he says. So the fuse was replaced with a nail. Now the thing about a nail is, a nail doesn't blow when a fuse blows. So the electricity carries on through at whatever power it's going to draw, and then this thing was actually allowing electricity straight through and not switching it. That would have meant there was too much power, this wouldn't blow, so these were the next things to start blowing. Possibly with power then actually, you had basically a cascade failure where other stuff across the board failed. So again, I've replaced these two. Now I've diagnosed, after trying it in my CNC earlier, the spindle span just a tiny bit and then the fuse blew, but it span without being turned on here, which is the spindle switch. And I think I was saying earlier, spindle switch actually supplies the 555 for the signal to this transistor. It doesn't supply the spindle directly. So if that was turned off when power went on and this turned on, it meant this had to be at fault. And I took my multimeter to it, and I mean, if I take your multimeter across a couple of those pins,
Dad,
I'm off screen there.
The
Previous owner knew less than me, and didn't have a spare fuse. I think the previous owner, maybe they had a condition where it kept blowing, and instead of diagnosing why it kept blowing, they were trying more and more fuses, and maybe got sick of it and put a nail in. I think that's what I'm diagnosing here, and I haven't managed to get my hands on the right kind because I may have to spend some time thinking about it. I was thinking about putting a PTC, which is a positive temperature coefficient. It's, I gotta say, it's what they call a thermal fuse. Yeah, everyone's as confused as you. I know, I'm using acronyms all the time. So what it is?
What's an acronym?
It's 3-letter things.
Like a CnC.
Yeah, exactly. Hey, you're not in shot, by the way. You're looking over there. So, what that does, it's a resistor that will get, the resistance will increase as the current gets higher. So if you get something that goes into some crazy high current condition, it's a bit slower acting than a fuse. So a fuse is what you really want, and a nice fast blowing fuse. But what the PTC will do is it will increase resistance, thus slowing the amount of current going through the device, thus protecting the device somewhat. And they are common to see with motorized devices. The reason it's called PTC, okay, so positive temperature coefficient. What that means, there's a coefficient. So there's a graph that goes upwards, which is resistance against the temperature. Because you've also got a one that can go the other way as the temperature goes up, where the resistance goes downwards, which is a negative temperature coefficient. So they've got ones that go both ways, and they're used for controlling devices depending on temperature. Some people you can also just use them as sense devices, but in this case, the resistance is directly what you want because you want to control the current based on the temperature. I had trouble speccing one that I could use with this that would handle the current required, because I was going to see if I could do something where you've got these two really big resistors, the shunt ones, but then if I replace those, it would end up shunting current back through this 100 ohm and blow that again. So I'd have to put it in series with these two instead of in parallel.
So whoever hurt this poor thing?
It was destroyed. It was
destroyed by,
right.
I think it was Lee Lipinski.
No, it wasn't. It was the previous owner that. Look,
Really?
you're saying. Look. Yeah, no. It was. So he got it from a previous owner who destroyed it and then sold it. I don't think that's coming out. Can you get me the other pliers? There's another set of pliers. You got them. Yeah,
one?
that one. That's it. Perfect.
Oh, there's a big G-clamp and a little G-clamp.
Yeah. I got big
How many
little.
G-clamps have you got?
Oh, they came as a set. There, got 3 of them in the same set, different sizes.
Huge, mini, medium.
No, that isn't okay.
I don't get it. Oh, nothing.
Oh, no.
On the chat box.
Looks like it was coming out.
What was it on now?
Don't know. No, look, that isn't actually any washer. That is just that's thermal paste that's turned completely ceramic. I thought it was some kind of ceramic thermal washer jobby. I don't know. Well, yeah, but I don't really think it's gonna. Yeah, it doesn't fit. It's not gonna have the right thermal properties. Okay. do I... That still looks like it's going to do the trick. Okay. So what I'm going to do... Where was the screw?
Screw? What screw?
Oh, this one here. Okay.
Oh, wait, it's this one here.
It's definitely not that one.
Too long. What about this one? Dad, is it this one? Too short?
No, it's going to be this one because that one's got a nice... it's got a nice wide base. Yeah, it's the same type. That's fine. Okay.
I think there's another one over here, Daddy.
Oh, there's screws everywhere. I just had to find the one that was where I put it before.
Wait, what? Daddy!
You're in a part of my lab which is like a holding pin. For... Oh, that's not going in. Why is that not
explain, mate. Thumbs up.
Can I ask you a question off topic? Depends on how off topic, but go on, give me a go. I'll see what I can answer.
Yeah, please.
Huh?
I'll see what I can too. Hopefully it's about ancient Egyptians.
Oh, that's what you've been doing at school, right? I see, ancient Egyptians. Ramesses II and the Valley of the Kings, eh?
Yeah. Tutankhamun. Why are there no doorbells on a pyramid? Because you could just toot and Khamun.
Oh, you've been storing that up all day. This is interesting. Yeah. So these look like these were turned pins. These are flattened pins.
Flattened pins?
Yeah, what I'm going to...
Are you going to solder it in, though, Dad?
Yeah, but first I've got to actually get it to go in. It's not... It is basically the same profile. It's just fighting me.
Fighting you? What do you mean fighting you?
Go on then. Anyway, loose prob. You can go and ask away.
Ask away! Yeah, there's nothing on the chat screen yet. Well, there is things, but old things. Like when somebody said, what's the fault on the machine? Huh?
Okay, right, I'm just gonna see. Is that because I've yet to clean these out further? I mean, it's still... Okay, I'm gonna go over that with the braid. Let's just chop off a little bit.
So this is what you do in live. I've never been on live.
Oh, I guess, yeah.
Yeah. I never knew that you
dual cascading regulators with auxiliary filters. Whew, okay, Helena, you're completely obscuring the camera. Right,
What?
Okay, so I'll infer what I do know. I'm not sure I'm going to be able to answer that exactly. My understanding probably is that you're talking about using, as in a voltage regulator to regulate a DC voltage or DC-DC converter. Big yawn, everyone saw that big yawn. Lovely. It is late for her.
What does LOL mean?
LOL means laugh out loud. Okay, so cascading regulators. I'm wondering if you're talking about using a DC regulator, and I know there is a slightly cheeky trick you can use where if the regulator's a 5-volt regulator and you want to be able to deal with more current than the 5-volt regulator can deal with, you can then put another FET on the end of the regulator output with a larger current handling capacity, and as long as you've then got a capacitor to smooth it, you should be able to get higher current still at the same voltage because there's still the same loops going round, because via that ground I believe you've got an op-amp feedback loop. But I might be way off. I'm afraid dual cascading regulators, I am guessing. Auxiliary filters just means extra filters. But again, I'm afraid I'm guessing there, loose prop. I'm not entirely sure about that one. So
LOL. I don't like that word.
What, lol, laugh out loud? It's just standard internet speak.
I'm not sure why they use it.
What, laugh out loud? It's pretty...
Lose prop.
Referring to a video transmitter to reduce noise. Oh.
What does it mean?
Well, there we go. So someone on the channel knows. That's cool. Doesn't matter if you don't want to be trying to work out as a fancy term for basic.
Something basic.
It's a good question. I can't answer that, but maybe Laser Knight can.
Laser Knight? Yeah, go and ask Laser Knight.
He's just there.
Oh, he's there.
Yeah, he's one of the other people on the channel there. You see him?
I never knew you could see them, even if you're on the chat.
Well, no. The people chatting can see each other. Can see each other's chat.
Cool.
The only funny thing about these live videos is YouTube then publishes the video, which is cool. But the thing is, I know it's cool. It's great.
Not cool.
I like that. But the only thing I don't like about the published video, after there's been lots of chat activity, is you don't get the chat activity. So it's all published without any context, and people go, well, what's he on about? And of course what they can't see is that I'm answering chat that's then long scrolled away.
No, don't ask me.
Well, because he's not sure either. Yeah.
Don't ask someone else, maybe later night or lose pop.
Okay, I presume he was just talking about electronic voltage regulators, which is the regulators I know about. I don't know about other types. Now, this is weird. It doesn't want to really go in. I'm going to compare it with the ones I used on my board. Hold on. Let's get is it over in this?
Dad, what about this other board? It looks the
Hold
same.
on. Ah! Helena's gone. What about this board that looks the same? Now, this board is... Oh, this board is very close to being the same board. There are some distinct differences.
You see the case?
Apart from the blown up stuff, obviously, and the broken stuff.
And the black dot.
The black dot?
Yeah, see the black dot.
Oh yeah, that's to be honest, that's a trivial. That doesn't really mean a lot. That's just what's in it. So you notice the connectors here are different. You see that? So I've got a 2-pin connector with a gap, and then a smaller 2-pin connector, and here there are two 2-pin connectors. Oh, chat is delayed. Thank you. That made sense. Oh, okay. Mine did make sense. Cool. The fan on Lee's board has been moved down to here. The fan pins, yeah. And you notice my board is only single board. It's a single-sided board. So this side you got all these tracks, and this side there's no tracks at all. Yeah, can you see that? And watch out! Don't rock the table. Don't rock the table. Here we go. Look, you might be able to see it in the monitor there. So here on my board, you've got also some jumpers. Yeah, you see those little bits of wire there? On Lee's board, instead, there is... It is Lee Lipinski's board. So on this one, there is actually an upper layer where mine is bare. And you've got a track going along here for the fan. And those jumpers have been replaced by tracks here and here. Spindle connector is different, and you'll notice that, look, the spindle connector, the connector is the other way up. So if you look, the polarity of the one on mine, it's got the tab on this side, and the one on Lee's has got the tab on this side. I mean, they're all fairly small differences, apart from the polarity on the spindle, which I was talking to Lee about earlier, actually, before we started filming.
What? So you're going type on your phone or tablet?
Yeah, we were. Yeah, exactly.
Send.
So yeah, there are small differences. They may be mostly cosmetic. I mean, you know, the fan change is different. Those things are different, but actually the overall circuit is the same. As far as I can see, the component counts are the same. There's no additional filtering. Actually, the other minor difference is probably because of that fan is, so yeah, that's different. Is that this capacitor and this capacitor, the one on
somewhere over here,
yeah, on Lee's board, this capacitor, sorry, on my board this is a 25 volt, and on Lee's I think it's only an 18 or 16 volt, but it's only running at 12 volts anyway, so it's fine. And I suspect they've done that to save space to fit the fan here. Chat is delayed. It means there's some lag on the chat. I suppose the only other thing with chat though is the chat doesn't actually appear, I believe, in the published version that YouTube put out. Which is, right. Sorry. What I was going to do is I was going to go to my own stock of these, because I had a stock of things that I bought for my CNC, and I'm just trying to figure out where I've put them. No, it's not in that box. This one over here. Is there a blue box that has CNC written on it? Oh, there is. Hold on a minute. I'm going to do something awful and lean over the camera because of where it's stored. Sorry. Right.
That's where we used to keep the Lego.
Ah, right. Ah, well, we've got boxes and boxes of Lego.
boxes and boxes. We've got 3 boxes now.
And do I have them in here?
That makes about...
That's the 7812 regulators. So, do I use... Oh no, right. Okay. So, Lee, do I use my board or am I using an Arduino? Alright. Let me show you guys the inside of my CNC machine. It's probably a bit more fun than watching me struggle through soldering or trying to get that part in there, which I will do. And I'll show you what I've got going on in mine. Let's just make some room because it's actually, those control boxes are fairly big. We can get rid of that because that's now junk, I'm afraid.
What?
Main camera is focused on the soldering iron, not the boards. Yeah.
Please, please, please. Oh, good. It's not on automatic focus.
No, I know. I'm going to try and change the focus of the thing. Okay, right. That's also because I'm clearing it as well. So giving it less to focus on. I think something is wrong with my screen.
Oh, Dad, they're the same.
Right. Okay, my CNC board. Okay, then I'll talk you through some of the mods.
Mods? What do you mean?
Modifications.
Modifications. What's a modification?
A change. Just turn off the iron, because I can always come back and solder off camera. We can talk through this instead.
I'll see you later.
Oh no, I'm not turning off the camera. Yeah, just.
I meant
okay, so at the moment I've taken out the. Hold on, let's go over this way.
Main camera has focused on.
Hold on, Helena, you're leaning on it and making everything. Right. So I've taken out the power board, but I'm still using the same power board even when using the Arduino, and I'll show you what the Arduino is doing.
Who's Nick?
So,
oh, Nick Stacks are going up.
Oh, hello, Nick Stoker. Yeah, it does sometimes do the soldering iron, I suppose. I've seen it. So on the back of here, you've got the 3-stepper motor control or outputs and the spindle output. You've got this parallel port. Now, I didn't really fancy having a PC with a parallel port tied to this thing. I just wanted to save some space, and you know, frankly, I want to be able to talk to it by USB. Now, when I get round to it, instead of having this hole there, it'd be nice to have a USB socket here. I'm not going to plug it in right now because the rest of this isn't ready. But I know, you're thinking right. So, Lee's probably familiar with the inside of this because he's got one too. So you've got this big old toroidal transformer. Hold on, yeah. And that's supplying power to this board, which not only does the spindle turning, regulate. Yes, so I'll get to that one.
How many chips are in this board?
I'll show you.
2?
Hold on.
5? 20?
Lots. Lots and lots. This is the short answer.
55.
So I've got my... Oh, I managed to put a potentiometer back, but it's still not quite right. I had that coming out the back at one point as a mod. So you've got your 2 switches at the front for main power and spindle power. And Lee's spindle was actually turning on when I turned on main power only. I didn't have to even turn on spindle power. And there's a big emergency stop. The emergency stop, actually, is only really a signal to the PC. It never did anything to stop the spindle going. So
power spindle.
Yeah.
Emergency
spindle is the spinning bit.
Emergency stop. I made
Okay,
one of those on my
so under
days.
this, and I'll get to what's in there, here is the stepper control board. So each of these are Toshiba, what, TB5560AHO. So each of these are stepper controller chips, and they can shunt quite a lot of current through them. Hence why there's a big fan here. So that fan will pull it across over there. How old is this? It's only about 3 or 4 years old. You remember me? You were in the video where I took this out of a box and started screwing it together. You were filming me. Oh, that film's somewhere on my YouTube. These are the 3 outputs to the to the steppers. You've got just some big caps here. I suppose that's to keep the noise away from. You've got these, which here, these are optos. What these do? So you've got these little ones and these bigger ones. They basically mean you can have power coming in from the computer. Yeah. How do I know? Because I've spent a lot of time in this circuit having a good look at it. Lots and lots of time mapping it out because I've blown it up again yet. He hasn't seen a working one yet. Oh dear. Yeah, so those are so you can basically control from one circuit another circuit, and they use light to share signal. but the electricity between the two is never shared. They might share a ground, but it means you're not going to get horrible power from one to the other. So you're interested in this bit. This is my Arduino. And the Arduino, yeah, so let's just unplug it and have a look. All right, this cardboard box is an old phone box, as in an old mobile phone case I've used just as a bit of a separator. And instead of a parallel port on the back, I soldered in, when I was doing some other fixes, there was a room for a header down here. So I soldered that in. So that's a ribbon connector. Ribbon connector goes to this board on the top, which is an Arduino proto board. I have to be careful because this is not polarized.
What does polarized mean?
Oh, polarized means stuck one way around.
Ooh.
Don't use a nose nail again, would you? So, got these headers in here.
Nice. You said that.
And you got some of my Lee Lipinski. So I got some of my horrible wiring on top, but my horrible wiring is taking this header to the correct. I did solder it a long time ago, but that takes this header to the correct pins to go to the Arduino, which is running some G-code firmware known as grbl, which is what's running on this, which is just a standard, pretty bog standard Arduino Uno. It's just got the gerbil firmware on it. And the gerbil firmware means... Oh, I've bent that pin out slightly. So the gerbil firmware means that this Arduino can interpret G-code and send the G-code to the board.
Don't use a nail again. What do you mean, don't use a nail again?
Oh,
You prop. Sorry if I say your name wrong. I can't pronounce it.
Do you know, I didn't notice this, but that's been there for a while. So these are all in right, but I didn't notice these two header cables aren't going anywhere. Do you know what? I should have done this a long time ago. For safety's sake, I'm going to trim those off. They're not wired into anything, I suppose, and they're just grounded, but I still don't like the idea of metal bits shorting that shouldn't be. Let's just get rid of that.
Oh no, oh no, oh no. I knew something was bad.
Oh, that was just a bit of... So I'll just... There we are. Get rid of those, because those could short something one day. Let's get this one out.
I'm reading that again. I don't know why.
So yeah, it means that I don't have to have a PC with a parallel port. I don't have to run what's it called? It came. I mean, oh gosh, that wasn't good. So I didn't have to use the Mach 3 control. I just used gerbil on this, and it means that then I can control it from a laptop with USB, and then I just need a G-code streamer. Now I've not gotten round to it yet. Oh, and then this board has been hacked, so I can flash different firmware on it. That's what this hacked sticker and this resistor's about. So I could actually go further with the firmware. That's another mod to the Arduino board. But at some point I may figure out how to put an SD card on it, so that I don't even have to G-code stream. So perhaps I could send code to it and then disconnect my PC. Right, I'm going to pop this back in. Now, it sounds like I'm being called off for food, which may mean it may be time to wrap up for tonight. I didn't get as far with the soldering iron as I would like. There were a number of questions and fun things, and I suppose I'm glad to have kind of gone through.
Ooh, nice.
Yeah.
From Lee Lipinski.
Lee, somewhere I've got drawings for this board here as well, so it is repeatable, and the gerbil firmware is still available. I believe it still fits on an Uno. They do recommend using an Arduino Mega.
Uno? What's an Uno?
It's an Arduino Uno board. It's the type of Arduino. Sorry, what's an Uno board? It's just one of the Arduino models.
I've never seen one.
Well, you've seen the Arduino.
I know, I haven't seen an Arduino board.
That's an Arduino board.
What's an Uno board?
That's an Uno board. It's just one of the models of the Arduino, but it was the popular one, the Arduino R3. It's one I loved. It was. Nice. I used them for a long time, and the funny thing is there was a point where I was using them for just about everything. It was like, yeah, you know what? At this point, a Raspberry Pi or something more powerful is more suitable. But,
everything.
Well, when I was building robots, I was using them because once you get comfortable writing code on a specific device, and with the the drivers on a specific device, it's great.
Stick with the factory kit to get the hang of it.
Ah, the factory kit. Yeah, okay, that makes sense, I suppose. Funnily enough, actually, I kind of came into CNC a little bit of a run, and I never did use the factory kit. I went straight for this. I did go and buy a PC that had a parallel port on it because actually it turned out nothing I had in the house had one, which was amazing because there was a point where I used to have to debug and flash boards with them, and I think I'd gotten spoiled by Arduino where I could do everything over USB, and I had a PIC kit that I could do over USB as well. So I very quickly converted to do that instead. Okay, so the iron is off. I'm probably going to have to go and take a look at why one of these isn't fitting in and find out if I need some thermal gel for that, which is going to be a little bit of off-camera rummaging. And it also sounds like I'm being... Well, she's being called for food in bed, and I should probably have some food. So I think I'm going to wrap that up for tonight. I don't know. I've been on for nearly an hour. And Lee, the next you'll hear from me is I will have dropped one of these in, and we'll be testing this again and hopefully getting much better results.
Holiday.
Well, you got a holiday.
You haven't.
No, I might have a couple of days. So we'll carry on with this, Lee. Don't worry, we're not giving up on this yet.
No, on Friday night. Next week.
I've got a weekend of time to do some more soldering and get the new board, new part on the board.
Start tomorrow.
I was expecting tonight.
Cheers for the help.
I was expecting to get further with this when I tested it earlier tonight.
Brilliant, no worries. I don't know what you mean, Lee.
I was expecting to get further. I didn't expect it to be quite that broken, but I suppose that actually this being blown in its way explains a lot of the other problems. So there's, in a way, it was funny because these two blown explain why that was gone. This blown explains why the fuse kept going and why that went. So there's, again, it's what they call a cascade. Once one thing blows, other things start to blow.
For all the reply, I'm off to put my little one to bed. Cheers, night owl.
Yeah, I need to put my little one to bed too. I've got another little one too.
Two! Don't forget the other one!
I said I've got another little one too.
No, you said you had put my little one to bed.
Well, my little ones, yeah, okay. You're going to be, okay, yeah.
Correcting your grammar. Night, loose probes.
Would be easier to buy a new CNC. Not really. I mean, I know where you're coming from, but it is just the spindle board, and it is actually down to we should be able to replace this component and get somewhere.
Okay,
I will carry on going, and I know the problem is, I suppose Lee is waiting on me sending him back a working board. And again, to come clean, I sent him back a board before that wasn't tested nearly enough, sadly. So it was sent back to me with some more stuff.
Not Lee Lipinski.
No, Lee Lipinski and loose props are different. There just happen to be lots of L's in the chat window. You're getting confused.
Yeah, I'm getting confused with the chat window.
That's fair enough. Okay. Goodbye all. Thank you for watching, and Lee, I will keep you posted on where we get to next with this board.
I think that tomorrow we'll do another one because I really want to do more live
streaming. And for everybody, Helena, do you want to do the
Go make stuff and be awesome. I think you need to put the sign up more.
Hurrah. Yeah, go make stuff and be awesome. Night night.
Good night. Have a nice rest.